Learners, welcome to Engineering Chemistry lecture by Professor Makaran Kulkarni. Let us start the unit number 3, Advanced Materials and Techniques. Lecture number 2. What you are going to learn in today's lecture? We have to discuss the polymers, in which the first point, glass transition temperature. Second point, factor affecting the glass transition temperature. Third one, plastics. And fourth point is thermosetting and thermosoftening plastic. Let us start the part A, that is polymer. Glass transition temperature. The temperature below which the polymer becomes hard, brittle and glassy, and above which it is softer and flexible, known as glass transition temperature. Now look at here, this is the Tg value. Every plastic or polymer having its own Tg value. The temperature below which the polymer becomes glassy or brittle and above which it becomes softer and flexible, that temperature exactly known as a Tg value. And another one is the Tm, that is melting temperature, that the temperature above which the material or polymer achieve its viscofluid state is known as the melting temperature. In today's lecture, we have to discuss the Tg value of, or how the factors, various factors, those directly affecting on the Tg value. Okay, so factors affecting on Tg value. First one is crystallinity. Now here, higher the crystallinity of the polymer, higher is the Tg value. Why it is so? Because more is the crystallinity, more is the regularity, then less is the flexibility, and we can say higher is the Tg value. Second, if molecular weight is higher, the Tg value is greater. Polymer, if D, that cross linking of the polymer chain, means if the cross linking is higher in polymer, then also the Tg value increases or having a high Tg value. E, plasticizer effect. Plasticizer is the material which is added into the plastic or polymer to improve its flexibility. So as the addition of plasticizer of polymer, it decreases the Tg value because the flexibility increases. F, coiled polymer chains. Example is rubber. Rubber is a coiled structure. So if the structure of the polymer is coiled or spring like structure, having a lower Tg value. G, force of attraction between chains. Polymers having stronger force of intermolecular attraction have greater Tg value. Next is plastics. Plastic has a plasticity property. Plasticity is the virtue of which material undergoes permanent deformation when it is subjected to heavy stress or pressure. There are certain characteristic properties of the plastic. First, plastic is resistant to corrosion. Plastic is resistant to atmospheric oxygen. It is a bad conductor of heat and electricity. It resistance to acid, alkalis and solvents. It resistance to oil. So there are certain characteristics of plastic or good plastic, and due to which its use is in large amount nowadays. Sixth one, plastic increases the decorative value also. And lastly, seventh one, plastics are 4 to 6 times lighter than metals, but we can use in a various purpose, that is option to the metal. On the basis of the thermal behavior of the polymers, they are classified into thermo-softening and thermosetting polymer or plastic. Okay, so this is the distinguish between thermo-softening plastic and thermo-setting plastic. Name itself indicates that thermo-softening means the material which is soft on thermal heating is known as thermo-softening, and thermosetting means there is no any change in the physical change in plastic when the thermal heat is applied. Let us start the first point. Thermo-softening plastic are the polymers formed by addition polymerization, whereas thermosetting plastics are formed by condensation polymerization. Second point, thermo-softening plastics consist of long chain polymers with negligible cross links. So here long chain molecules are formed, obviously because of addition polymerization, but in case of thermosetting plastic they have three-dimensional structures. Third point is they can be softened on heating, and in thermosetting plastic they cannot be softened on heating. They can be reshaped and reused, thermo-softening plastic, and in thermosetting plastic they cannot be reshaped and reused. They are soft and weak, thermo-softening plastic, and in thermosetting plastic they are insoluble in organic solvents. Thermo-softening plastics can be reclaimed from the waste, whereas thermosetting plastics cannot be reclaimed from the waste. The example of thermo-softening plastic is polyethylene, PVC, polypropylene, etc. Whereas thermosetting plastic example is bakelite, melamine, formaldehyde, urea, formamide, etc. So on these both we can easily distinguish between the thermo-softening and thermosetting plastic. Okay, so what we learned in today's lecture about the glass transition temperature, Tg value. Then second, the factors affecting the Tg value. Third one, plastics. And lastly, the thermosetting and thermo-softening plastic, the difference. Okay, thank you very much.